The second part of the series on functions. Before watching this video, you should have seen the coordinate geometry series, quadratic equation series, and the video on Pythagoras theorem, as all of those concepts are applied in this. In the previous video, we looked at how to identify a function, its domain, and its range. In this video, we'll be looking at a type of function, and that is linear functions. What do you understand by the word linear? You'd probably say straight, and that is correct. Linear means straight, but in math we would say straight line. Anything that produces a straight line is a linear function. So linear function is any function that gives you a straight line. You're probably confused because in the previous video we looked at an input for a function giving an output. So how does this correlate with a line? To understand that, we need to take an example of a function. Now, we need to apply our understanding of coordinate geometry over here. Over here, we're giving the y input as an x, and then we get the output as a y. We know that from the domain. Our domain is a set of inputs, and our range is a set of outputs. Our domain is represented by x, and our range is represented by y. We know that this output for this function will give you the y value that coordinates to the x value. Now the y and x over here can be plotted on a graph. The x value, the input values you give, can be plotted over here, and the y values output you get can be plotted on the y-axis. So suppose you have 2, 2, you will have it over here. Your input is 2, your output is what? Now let us graph this equation or this function and then see what it gives us. I've already done that over here. F of x equals 2x plus 3. That gives you a straight line. An infinite straight line. It never stops. Now we are like, okay, I understood that it can be plotted, but why does it give a straight line and why is it infinite? We will look at that. For that, we need to identify the domain and range of this equation, of this function I mean. The domain of this function would be x belongs to R, because all possible real numbers can have 3 added to it. And our range will be y belongs to R. For input can be any number, our output can also be any number. So just imagine you have an infinite number of x values and an infinite number of y values. So it's gonna be going forever, it's not gonna stop. That's why over here the function, the graph, the line doesn't end. But why is a line plotted like this with a certain slope or gradient? To understand that, let's find f of 1, f of 2, f of 3, f of 4, and f of 5. For this function. So if you have the x value as 1, 1x, 1 2s are 2 plus 3, that's going to give you 5. 2 2s are 4 plus 3, that's 7. 3 2s are 6 plus 3, that's 9. 4 2s are 8, 11. 5 2s are 10 plus 3, 13. These are 5 values that fall in this function. The coordinates for these values would be 1, 5, 2, 7. 3, 9, and 4, 11, and 5, 13. These are all the set of coordinates that we have. Our input value and then our output value x and y, domain and range. Now let us plot this on a graph and see what it gives us. I have done that over here. We have all the 5 values that we got, and I just drew a line passing through all those points. This gives us the same line this gives us. We know that because the y-intercept is the same and the x-intercept is also the same. Now if you're going to ask me why does this equation have such a tilt, why it's like that, it's just slope. It's the values that you're getting. So you can see to this, as your input is increasing by 1, your output is increasing by plus 2. That's why there is such a slope. You can find out the slope using the slope formula too, and you would get the slope as 2. Now, do you think we can represent this function f of x equals 2x plus 3 as y plus 2x plus 3? Would this be right? It would be right, because what is the output? We just discussed this in the video. The output we get for this is the y value. So you're inputting the x value and you're getting the y value. And the equation has x value. When you solve for this using a variable, using a value, you get a y coordinate, which is the same as this. Let us plot this on the graph and check if it gives the same thing. Instead of f of x equals to x plus 3, if we do y equals to x plus 3, it's the same line. There is no difference over here, which means both of these are the same thing. And you'd probably know this is a linear equation. And we just discussed that this is the linear function. Any linear equation that is a function would be a linear function. I'll tell you the definition for a linear function. A linear function is any function that has either one or two variables and has no exponents. One or two variables with no exponents. One or two with no exponents. That is the definition of your function. We have one value over here, one variable, and then we have an exponent, so it's a linear function. Now you might ask, so okay, we just have this linear equation over here and we have this function. Why do we need this function? Before that, do you know what this is? It is your equation of a line. Y equals mx plus c. All lines have an equation. So does this function. It is just this represented as a function. When we just have an equation, we just substitute the values and find the output. But when we have a function, we imagine it as the x and y values on a graph. That allows us to plot such lines and then find out the x-intercepts, y-intercepts, gradients, pattern. So since function allows us to do all of this, and it also allows us to understand the relationship between the input and the output. So function is just a different way to represent a linear equation to be able to get more information about the equation itself. So let us take a look at a question. The cost of producing B tools by a company is given by the cost of producing B tools let's just say is given by f of b equals 1200 b plus 5500. All of this is in dollars. So first, what is the cost of 100 tools? Cost of 100 tools. Our B is the number of tools, so if you want to find f of 100, you would do 1200 into 100 plus 5500. If you find out the answer for this, you would get 1200. So 1200 into 5, that's going to give you 1,20,000. 1,20,000 plus 5,500, that's 1,25,000. 125,000. And then the next part is to find the cost of 101 tools. 101. So we'll do the same thing. F of 101, 1200 into 101 plus 5500. That would give you 121200. 121200. That is 1,21,200. So that's your f of 101. Now, the next part of the question wants us to find the slope. Find the slope of the linear function. To do this, first, we need to imagine it on a plane as a graph. So, this is our x value. Our input is always x value. So, you have the number of tools over here. And the output is the cost. So, we'll have the cost in dollars over here. Right? So, they want us to find the slope. This is fairly simple. If you remember the formula for slope, it is m equals y2 minus y1 by x2 minus x1. Our y2 over here is 121200 minus 125,000 divided by 101 minus 100. This gives you divided by 1. Actually, there is a mistake over here. I'm sorry. You have 121,200 plus 5,500. That would actually give you 126,700. So, if we delete this, 126,700. So we'll have 126,700. We'll just redo this part. So m would be 101 minus 100. And that actually gives you 1200 divided by 1. So your slope is 1200. This is all there is for linear functions. Linear functions, most of the time you won't get questions. That is just about this functions, but you will have questions such as the one we did right now, where it relates with other topics like simultaneous equations and many other things. In the next video, we'll be looking at quadratic functions. Thank you so much for watching. Subscribe to our channel, like the video, and comment down your thoughts and doubts.